Today we're starting our unit on triangle similarity. So we will be developing triangle similarity and seeing what it takes to be similar. When we did the congruency, we had 5 of them. We had the side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg congruencies. But for similarities, we only have 3. So, how do I identify similar triangles and find missing measures is our essential question. I am learning to identify similar triangles and use them to find unknown quantities. Okay, you're given that P is circumcenter and find all your missing measures. So, can we find them all? No. Can we find some of them? Yes. So the ones that I know without any math at all are which ones? Pause the video and figure out which ones you can find. So the very first one, if this one's 8, this has got 3 tick marks, this is also 8. We know that the distance from the vertice to the center point there is the same. So this will be 9, this one will be 9. Now, I have right triangles. How do I find missing pieces with right triangles? Pythagorean theorem is correct. So if I want to find this measure here, I know that it is a leg. So 9 squared is equal to 8 squared plus b squared. If I take the 9 squared minus 8 squared is equal to b squared. The opposite of squaring is square rooting. So the square root of 9 squared minus 8 squared will be equal to b. Now, I can guarantee you that it's not going to come out as a pretty nice integer. So we will do rounding. And we end up with 4.123. So this is approximately 4.12. And we use the approximate symbol because it is not exact. Okay, so I've got this hypotenuse, I've got this leg, I can also find these 2 pieces. So this time, I know the hypotenuse and the leg. Instead of going through the whole, setting it up, moving the 1 over by subtraction, we're just going to start out knowing we need to subtract. So it will be 9 squared minus 7 squared is equal to b squared. Square root them both. 9 squared minus 7 squared is equal to b. This time it is 5.656, so that's approximately 5.66. So this one will be 5.66. With the tick marks, it tells me that this one is also the same. Can we find these lengths? No, because we have to have at least one more measurement. So we found all the ones that we can, and that's fine. That's good. So I want you to start thinking about triangle similarity. Looking at these triangles, what do you know from the picture? We know that angle A is congruent to angle D in the other triangle. We know that angle B is congruent to angle E in the other triangle. So what do we know about angles C and F? Well, if two of them are congruent, then the third ones have to be congruent also because of the triangle sum theorem. Angle C will have to be congruent to angle F. Okay, now that's an important thing to remember because if all your angles are congruent on a triangle, what's going to happen as you make it bigger and smaller? The angles stay the same, so they're going to be pulled in the same way. So if two angles of a triangle are congruent to two angles of another triangle, then the triangles are similar. Here's your congruent, and we used it up here. Here's your similarity. So if they're similar, we're going to use just that one, kind of looks like a sideways S. So we don't need to know all three are congruent because it's understood if two are, the third also have to be, because all three of them have to add up to 180 degrees. Okay, now this takes us to the next one, which is what we call the side-side-side triangle similarity. If three sides of one triangle are proportional, to three sides of another triangle, then the triangles are similar. So if you look at this with a side-side-side similarity, you have to check all three sides. You match the sides up. So if I'm looking at this, given these two triangles, prove that they are similar. So I'm going to look at it. I'm going to say, okay, which are my smallest two sides? On this one it's 6, so I've got 6. I'm going to compare it to 4. That gives me the fraction 3/2. I'm going to go to the middle side, 9. I'm comparing it to the middle side here, which is 6. I've got 3/2 again when I simplify. And finally, the largest sides, 12/8. They both have a factor of 4, so this is 3/2 again. So I can say that these two are similar because all three sides are in the same proportion. So triangle ABC is similar to triangle. Okay, from A to B is the small side, from D to E is the small side, small, medium, large. small, medium, large. D, E, F. Okay, so don't take any shortcuts. If you want, you can also always look at the decimals. So 6 divided by 4, 1.5. 9 divided by 6, 1.5. 12 divided by 8, 1.5. So if you're doing this, you can also just put it in the calculator and look at your decimal. Okay, yeah, the side, angle, side. Remember the congruency, it starts with a side and then an angle and a side. If two sides of one triangle are congruent, and remember that's our symbol, to two sides of another triangle and are similar, we're not doing this is a congruency that I was giving you. Remember, we're working with similarity now. Oh my goodness. Are proportional. To two sides of another triangle, and their included angles are congruent. There's where the congruent comes in. Then the triangles are similar by side, angle, side. Your similarity is that sideways S. Okay. Prove or disprove these triangles are similar. First thing, I don't have any angles marked. Are there angles that are congruent that are not marked, and if so, why? Well, hopefully you realize we've got these vertical angles. So, step one, prove an angle. Angle MVL is congruent to angle TVU. And those are vertical angles. So we've got the angle. Now we've got to prove that these sides are in the same proportion. There's two ways you can do it. You can either go from side to side on the triangle, or you can go from triangle to triangle. We'll show you both ways. My brain always goes from triangle to triangle. So if I am looking at 8 is smaller, 28 is smaller. So I'm going to look at 8 over 28. When I simplify it, I end up with 2 over 7. There's a factor of 4 in both. So these are your two smaller sides. I also look at 14 over 49. These both have a factor of 7, so this is also 2 over 7. If I want to go from triangle to triangle, the fractions have to be the same. So I would be looking at 8 over 14, the small over the larger. This would end up, both of them have a factor of 2, so this would be 4 over 7. Notice that they're not the same, but the fractions will end up the same. 28 over 49. They both have a factor of 7. This is also 4 over 7. So when you get ready to look for the side angle side similarity, I always enjoyed going from triangle to triangle. My teacher showed us from side to side on both of them. You're going to do it the way your brain prefers. So for me, I was doing it from triangle to triangle. My teacher always showed us one way. I always thought I was doing the problem wrong but getting the answer right, which was because my teacher did not explain the math could be done in more than one way. So that's why I'm teaching you there's two ways to do it. So how do you know you're successful? You're successful when you can identify similar triangles and use them to find unknown quantities. So these are your similarities, the SSS, the AA, and the SAS. Make sure you know what the differences are.